Hello everyone and welcome to this video on base system. In this video we'll see what are the different number systems and understand what are the symbols which are used for representing the number in that system. We'll see how to convert a number from decimal system to some other base and from some other base to a decimal system. Then we'll see a shortcut trick for converting a number from binary to octal or from binary to hexadecimal and vice versa. Then we'll finally understand how to add and subtract numbers in bases other than 10. So let us start. The base of a number system basically represents the number of symbols which are used in that number system. In our day-to-day life, we normally use the decimal system. In this decimal system, there are 10 symbols from 0 to 9. Hence, its base is 10. Likewise, in binary system, there are 2 digits, 0 and 1. Hence, its base is 2. For septenary, there are 7 symbols, 0 to 6. Hence, its base is 7. For octal, there are 8 symbols, hence base 8. For duodecimal, there are 12 symbols, numbers from 0 to 9, and then 2 alphabets. A represents the value 10, B represents the value 11. Likewise, in hexadecimal, there are 16 symbols, numbers from 0 to 9, and then 6 alphabets A to F, where A represents the value 10, B 11, then C will represent 12, D 13, E 14, and F represents the value 15. So these are the symbols which are used to represent numbers in different system or different bases. Let us now see how to convert a number from any other base into a decimal base. So any number n which consists of digits x0, x1, x2 and so on up till xn in base B can be converted into its decimal equivalent by using this formula. The number n can be written as x suffix n into b raised to n plus x n minus 1 into b raised to n minus 1, where xn represents the nth digit in the number and so on so forth up till the last digit x0. So the value of n in this expression is 1 less than the number of digits, minus 1. So let us take an example and understand how to apply this formula. Let us consider this number in base 8, 246 in base 8. Now if you want to find what is the decimal equivalent of this number, so for that we'll have to first find out the value of n. For that the number of digits is 3, so the value of n will be equal to 2. Now what we will do is we will simply multiply each of these digits by successive power of 8 starting from 8 square. So the first digit will be multiplied by 8 square, then the next digit will be multiplied by 8 raised to 1, and then the last digit will be multiplied by 8 raised to 0, and then we will add them up. So this will be 8 square into 2, which is 64 into 2, plus 8 raised to 1 into 4, so this will be 8 into 4, plus 8 raised to 0 into 6, which is 1 into 6. So if we solve it, this will be 128 plus 32 plus 6. This is 160 plus 6, which will come out to be 166. So this is the decimal equivalent of this number 246 in base 8. Let us now see how to convert a number from base 10 to another base. Let us take the same example that we have considered above. If I want to convert this number 166, which is in base 10, to a number which is in base 8, we already know the answer. It is 246. Let us see how do we arrive at this answer. So for that we'll have to first find the highest power of 8 contained in this number. We know 8 raised to 1 is 8, 8 square is 64, 8 cube is 256. Now 256 is bigger than 166. Hence the highest power of 8 in this number is 64. Hence the highest power of 8 in this number is 2. Therefore this number in base 8 will be a 3-digit number. which is 1 more than the power. So it will be a 3-digit number. Now all we'll have to do is divide this number by successive power of 8 and take the coefficient. So first we'll divide 166 by 8 square, which is 64. So 64 into 2 is 128. We'll be left with a remainder of 22 plus 16, that will be 38. So 64 into 2, the quotient will be 2. We'll note down the quotients. Then next we'll divide 38 with 8 raised to 1, which is 8. So 8 4 is 32. So the quotient is 4. The remainder is 6. Now we'll divide 6 by the next power of 8, which is 8 raised to 0. So 8 raised to 0 is 1. 6 divided by 1, the quotient is 6. And the remainder will now become equal to 0. So this is how we can convert a number in base 10 into its equivalent value in some other base. Let us now take another example in which we will convert a number from binary system into decimal system and from decimal system to binary system. So let us take this example 1011 01 001. This number is in base 2 and we want to find what is its base 10 equivalent. So by applying the same formula, first of all we'll need to find what is the value of n, which is 1 less than the number of digits. So number of digits, if we'll count, this is 1 2 3 4 5 6 7 8 9. So the value of n will be 8. So we'll start multiplying these numbers by successive power of 8 2. So 2 raised to 8, then this number will be multiplied by 2 raised to 7, then next will be 2 raised to 6, then this number will be multiplied by 2 raised to 5, all the way up till 2 raised to 0. So let us see what is the answer that we will get. So this is multiplied by 2 raised to 8. 2 raised to 8, as we know, is 512. Then 2 raised to 7 into 0 will be 0. 2 raised to 6 into 1 will give us 64. Then 2 raised to 5 into 1 will be 32. Then 2 raised to 4 into 0, which will give us 0. 2 cube into 1, which will give us 8. Then this is 2 square, which multiplied by 0 will give us 0. Then 2 raised to 1 into 0, again 0. Then finally 2 raised to 0 into 1, which will give us the value as 1. Now all you have to do is add them up. So this will be 512 plus 8 will give us 520. 520 plus 96 will be 616 plus 1, 617. So this is the decimal equivalent of this number. Now let us see one more example. Let's take this number, which is a fraction, 0.1011. Now if you want to convert this fractional part, which is in base 2, into its decimal equivalent, so how we will do? Like in this integer part, what we are doing is we are multiplying it with reducing power of 2's, 2 raised to 8, 7, 6, 5, 4, 3, and then the last digit was 2 raised to 0. So we will continue going to the right hand side. This was 2 raised to 0, so this we will multiply it with 2 raised to minus 1. Then the next number with 2 raised to minus 2, then 2 raised to minus 3, 2 raised to minus 4, and so on. And we will add them up and we will get our answer for the decimal equivalent of this number. So let's see what we are going to get. 2 raised to minus 1 into 1 will give us the value 1 by 2. Then 2 raised to minus 2 into 0 will be 0. 2 raised to minus 3 into 1 will give us 1 upon 2 cube, which is 1 by 8. Then this will be 2 raised to minus 4 into 1, which will be 1 upon 16. Now we'll have to just add them up. This will be 0.5. This will be 0.125. This will be 0.0625. So by adding, we'll get 0.5 plus 0.125 will be 0.625. 0.625 plus 0.0625 will give us the answer as 0.6875. So this is the decimal equivalent of this number. So you can convert even an integer number and even a fractional part also. Let us now take another example for converting a number from base 10 into binary equivalent. Let us take this number 234 in base 10 and we want to find it what is its base 2 equivalent or the binary equivalent. So for that, again we'll first have to find out what is the highest power of this new base in the original number. So 2 raised to 7 as we know is 128, 2 raised to 8 is 512. Now 512 is bigger than 234, hence the highest power of 2 in 234 is 7. Now again we'll have to successively divide this number by reducing power of 2 starting with 2 raised to 7. Now since the highest power is 7, hence this number will be an 8 digit number. 1, 2, 3, 4, 5, 6, 7, 8. So we'll start dividing 234 with 2 raised to 7, which is 128. So 128 into 1 will give us 128 and it will leave a remainder of 106. So we'll now divide 106 by the next power of 2, which is 64, 2 raised to 6. So 64, again 64 ones are will be 64, it will leave a remainder of 42. Then we'll divide it with the next power, which is 2 raised to 5. So we'll divide it by 32, 32 ones are, it will leave a remainder of 10. Now with the next power, it is 2 raised to 4, which is 16. Now it is not divisible by 16, so we'll simply put a 0. Then with the next power, which is 2 cube, 8, 8 ones are, remainder is 2. Then we'll have to divide it by 2 raised to 2, which is 4. Again not divisible, so we'll put a 0 here. Then we'll have to divide it by 2 raised to 1. So 2 raised to 1, this will give us the answer as quotient as 1. The remainder in this case will be 0. Now 0 divided by 2 raised to 0, which is 1. So the quotient will be 0. So this is your binary equivalent of this number. Now let us see how to convert a fraction part of decimal into its binary equivalent. Let us take this example, 44.1625 in base 10, and we want to convert it into its binary equivalent. So we will convert the integer part separately and the decimal part separately. For the integer part, as we know, we'll have to first find what is the highest power of 2 in 44, which is 2 raised to 5, 32. Hence the highest power of 2 is 5. So we'll start dividing it successively with 2 raised to 5, then 2 raised to 4, 2 raised to 3 up till 2 raised to 0. So first we'll divide by 32. It will give us a quotient of 1 and remainder will be 12. Then next we'll have to divide it by 16. It is not divisible, so we'll put a 0. So then 12 by 8, it will leave a remainder of 4. 8 ones are is 8. Then we'll have to divide it by 2 square, which is 4. So this will give a quotient 1 and remainder will be 0. Then we'll have to divide it by 2 raised to 1, which will give us a quotient 0, and then by 2 raised to 0, which will again give a quotient of 0. So these two numbers will become equal to 0. So this is the conversion for the integer part. Now to convert the fractional part, what we will do is we'll multiply this fractional part, which is 1625 or 0.1625 by the base. So the base in this case is 2. So we'll multiply it by 2 and take the integer part of this value. So this will become 0.3250. So the integer is 0. Then we'll again multiply it with the base, which is 2 in this case. This will give us the value 0.650. So again the integer part is 0 here, so we'll write 0. We have to put a decimal and then continue forward. Then again we'll multiply it by 2, so this will become 1.30. So now the integer part is 1, so we'll write 1, and then we'll take only the fractional part, which is 0.3, and multiply it by 2. So this will become 0.60. So again the integer part is 0. Then again we'll multiply it by 2. This will give us 1.2. So again we'll take just the integer part and write it down. And this will go on. Based on the options given in the question, you can decide for how long you want to continue. So this is the base 2 or the binary equivalent of this number. So this is how you can convert a number from decimal system into some other base or from some other base into decimal system. Let us now understand some trick for converting numbers from binary system into octal system and from binary system into hexadecimal system by using some shortcuts. Now this is possible because this binary and octal, the base of binary is 2, the base of octal is 8. For hexadecimal the base is 16. As you can see, all these bases are some power of 2. This is 2 cube, this is 2 raised to 4. Even if the base was 4, if you want to convert from base 2 to base 4 is basically 2 square. We can do this by using a shortcut trick which will help us in saving a lot of time. Because if you want to convert by using the usual method, we'll have to first convert this binary number into base 10 and then that base 10 number into the hexadecimal or the octal number as per our requirement. But that long route can be avoided by using this shortcut technique. Let us take this example 111011010. This number is in base 2, and if you want to convert it into say base 4 or base 8 or base 16, let us see how it is to be done. Base 4, as 4 is equal to 2 square, base 8 which is equal to 2 cube, base 16 which is equal to 2 raised to 4. So what we will do is we'll club these numbers in some groups. So if you want to convert it into base 4, we'll club these numbers in a group of 2. So we'll take this group. So if you want to convert it into base 8, we'll club these numbers into groups of 3 since the power is 3 here. So we'll take this group. And since there are only 2 numbers, we can put a 0 ahead and consider it as a group of 3. Likewise, if you want to convert it into base 4, we'll have to consider these numbers into groups of 4. Likewise, if you want to convert it into base 16, we'll have to consider these numbers in a group of 4. Likewise, if you want to convert these numbers into base 16, we'll have to consider these numbers in a group 4. Now, how to convert this from base 2 to base 4? Let us take base 4 first. So after forming these groups, what we will do is we'll write the decimal equivalents of these numbers and then simply we'll arrange them. We'll get our base 4 equivalent. So as we know, this is a 2-digit number in base 2. To convert this into base 10, all we'll have to do is multiply this last digit by 2 raised to 0, second last digit by 2 raised to 1. So the value of this number will be equal to 2. Likewise, for this group it will be 2. For this group also it will be equal to 2. For this group it will be 2 plus 1, which is 3. And now we'll have to just simply write this number 3, 2, 2, starting from left hand side. So this is our base 4 equivalent. So as you can see, you can save a lot of time. Instead of first converting this into base 10 and then converting into base 4, you can directly convert it into base 4. Let's see how to convert this into base 8. Now the group of numbers that we have taken for base 8 is 0, 1, 0, then the next group is 1, 0, 1, and the last group, since we have only 2 digits, will put a 0 ahead. So this will be, so now we have to write these groups. So now we'll have to write the decimal equivalent of these groups. So first digit will have to multiply it with 2 raised to 0, then 2 raised to 1, then 2 square. So the value of this group will be equal to 2. The value of this group will be equal to 4 plus 1, which is 5. For this group it will be 2 plus 1, which is 3. Hence the base 8 equivalent of this number will be equal to 352. So if you want to convert it into base 16, we'll have to consider the groups of 4, which will be 1, 0, 1, 0, this first group of 4, then the next group of 4 will be 1, 1, 1, 0. And then we'll write the decimal equivalents of these numbers. So this will be 2 cube, which is 8, plus 2, which is 10. Now in base 16, we do not have any value as 10. We represent 10 by the letter A. So this we'll write it as A. And this will be 8 plus 4, which is 12, plus 2, which is 14. So in hexadecimal system, 14 is represented by the symbol E. So the base 16 or the hexadecimal equivalent of this base 2 number will be A into E in base 16. So this is how you can easily convert any number which is in base 2 into its equivalent into its base 4, base 8, base 16 equivalent. Remember, you can use this concept only when the bases are of the format 2 raised to n. Now let us see how to convert in the reverse way. If you want to convert this base 16 number into base 2, how it is to be done, or base 8 or base 4 into base 2. Let us see how it is to be done. Let us take this example of a base 16 number which is B84A in base 16. Now if you want to convert this number into base 2, so for that 16 is 2 raised to 4. So to write the binary equivalent of this number, we'll have to represent these individual numbers into binary system in a group of 4, since the power is 4. So A, which is 10, can be represented in binary as a group of 4 numbers as 1, 0, 1, 0. You can check. Likewise, 4, the next digit 4 can be represented as a group of 4 numbers. It can be represented as 0, 1, 0, 0. 8 can be written as 1, 0, 0, 0, and then B, whose value is 11, can be written as 1, 0, 1, 1. Now all you'll have to do is write down these numbers in the sequence. So starting first with B, 8, 4 and 10 in the same sequence in which this base 16 number has been written. So this will be 1, 0, 1, 1. First we have written for B, then we'll have to write for 8, which is 1, 0, 0, 0. Then for 4 it will be 0, 1, 0, 0. Then for the alphabet A it will be 1, 0, 1, 0. This will be the base 2 or the binary equivalent of this number. So this is how you can easily convert a number which is in base 16 or base 8 or base 4 into its binary equivalent without having to first convert it into base 10 and then converting it into base 2, which will help you in saving a lot of time. Let us now understand how to add and subtract numbers in bases which are other than 10. So let us take this example, 455 plus 444. Now these numbers are not in base 10, these are in base 8. So how are we going to add these numbers? Let us first understand how do we add numbers in base 10. So let us take this example, 189 plus 25. So if you want to add these numbers, first we'll add the units digit, which is 9 plus 5, which will give us 14. Now we cannot write 14 here because the digits available in decimal system are only from 0 to 9. So there is no representation for 14. So what we will do is we'll write this 14 as 10 into 1 plus 4. So this additional part 4 we'll write here. And since 10 is multiplied once, so we'll take this carry over 1 over here. And now if you want to add, we'll get 1 plus 8, which is 9 plus 2, 11. Now again, we cannot write 11 here. We'll have to split this up as 10 into 1 plus 1. So this one we'll write here and this one will take carry over here. So now 1 plus 1, it will give us 2. So this is how we add numbers in decimal system. The same concept will be used in system which are other than the decimal system. So if you want to add these numbers, 5 plus 4, it will be 9. Now we do not have this digit 9 in octal system. In octal system we have only digits from 0 to 7. So we'll break up this 9 as 8 into 1 plus 1. So we'll write this one here and take this one as carry. So this one will come here. Now this will become 1 plus 5, 6 plus 4, 10. Now again we do not have any representation for 10. So we'll again break it up. It will be 8 into 1 plus 2. So this 2 will come here. And this one will go in the carryover. Again it will become 10. So this will again rewrite it. We'll write 2 here, 1 carry, and then it will be 5. So this is how you can add numbers in base 8. You can do the similar addition in bases which are other than decimal system. Let us now see how to subtract numbers. Let us take this example, 544 minus 666. This is in base 8. So let us first understand how do we subtract numbers in base 10 or in the decimal system. So let's say if we want to subtract 96 from 124. So how we are going to subtract? First we will subtract the units digit, but here since 4 is less than 16 we cannot subtract. So what we do normally is we take a carry from the previous digit. So this will become 1 and we'll take a carry of 10. So this 10 plus 4 will become 14. Why we are taking a carry of 10? Because the decimals in the decimal system the base is 10. That's why we are writing a carry of 10. So now this will become 14. 14 minus 6 will give us value as 8. Now we'll have to subtract the tens digit next. So 1 minus 9 is not possible. So we'll take a carry. This will reduce to 0 and we'll take a carry of 10. 10 plus 1 now will become 11. 11 minus 9 will give us 2. So 28 is the answer. So in similar way, here we have to subtract 6 from 4. Now 4 is less than 6, hence it is not possible to subtract. So we'll take a carry from the previous next digit. So this will reduce to 3. And now we'll take a carry which is equal to 8. As in decimal system, we are taking the carry as 10 because the base was 10. Likewise in octal system, since the base is 8, the carry part will be equal to 8. So 8 plus 4 will become equal to 12. 12 minus 6 will give us the value of 6. Now again we have to subtract 6 from 3. It is not possible, so we take a carry. This will become 3 and we'll take a carry of 8. So 8 plus 3 will become 11. 11 minus 6 will become 5. Similar way, this will be reduced to 4. We'll get another carry as 8. 8 plus 3 will become 11. 11 minus 6 is 5. And then finally we'll write 4. So this is how you can subtract numbers in bases which are other than 10. So the only thing that you need to take into account is that while taking the carry, the number is not 10. It has to be equal to the base of that system. Let us now see how to add numbers in binary system. For that you need to remember certain rules. 1 plus 0 in binary is equal to 1. 1 plus 1 in binary is equal to 0 plus 1 carry. Likewise, 1 plus 1 plus 1 in binary is 1 with 1 as a carry. We'll understand how we are getting these relations. Let us take one example. So if I want to add, let's say 1011 plus 4 times 1. So how we are going to add? We'll use the same concept that we have used in addition of base 8. So this is in base 2. So now if we add 1 plus 1 will become equal to 2. But in binary system we do not have any symbol for 2. We have only two symbols, 0 and 1. So we'll have to split this 2 and we'll write it as 2 into 1 plus 0. So we'll write this extra part over here and then this one will go into the carry. So from here we are getting this 1 plus 1 is equal to 0 with 1 carry. Now we have to add this 1 plus 1 plus 1 which will become equal to 3. Again we do not have any symbol for 3 in binary. So we'll split this up, 2 into 1 plus 1. So this extra part we'll write it here. This will be 1 here and this multiplication part 1 will go in the carry. So 1 will come here. So from here we are getting this 1 plus 1 plus 1 is we write 1 and take 1 as carry like we have done in this case. Now again 1 plus 0 is 1, 1 plus 1 is 2. So we'll have 0 here and 1 carry. Then 1 plus 1 plus 1 is 3. So we'll write 1 and take 1 as carry. This 1 will come down. So this is how you can add numbers in binary system. So for adding numbers in binary system, you don't have to really break up these things. If you just remember these three numbers, these three additions, you can easily solve your problems based on binary addition. Now let us see how do we subtract numbers in binary system. Let us take this example 1101 minus 1010. This is in base 2. So 1 minus 0 is straight away 1. From 0 we have to subtract 1 which is not possible. So we'll take a carry. This will become 0 and since it is in base 2, the carry over part will be 2. So 2 plus 0 is 2. 2 minus 1 will be 1. Then 0 minus 0 is 0. 1 minus 1 is 0. So this is the result of this subtraction. So in this way you can add or subtract numbers in bases which are other than 10. So this is all for this lecture. In the next video, we will solve some problems based on these concepts. Thank you.